Hello friends, in this video I'll be talking about rules for aromaticity. There are 4 rules for aromaticity. I have already made 3 videos about aromaticity, part 1, part 2, part 3. If you haven't watched those videos, please watch so. If you are in advanced level and you want to learn quickly about aromaticity, this video is for you. And if you are following my all video lecture series about aromaticity, so this video is also for you. So the rule number 3 says the molecule must contain 4n plus 2 pi electron. This is also called Huckel's numbers or Huckel's rule. So this is a formula, 4n plus 2. So n is any number starting from 0 up to any 100,000. So if you put n is equals to 0, then 4 times 0 is 0 plus 2, that becomes 2. If you put n equals to 1, then 4 times 1 is 4 plus 2, that becomes 6. If you put n is equals to 3, then 4 times 3, if you put n is equals to 2, then 2 times 4 is 8, then 8 plus 2 is equals to 10. If you put n is equals to 3, then 3 times 4 is 12, then plus 2 is equals to 14. This is how you can change the number in the n yourself to make a table, and that table will guide you to identify which compound is aromatic or not. And if you don't want to make table, here's a quick shortcut: 2, 6, 10, 14, 18, 22, 26. The compound, if the compound is going to be aromatic, it must possess 2 pi electrons or 6 pi electrons or 10 pi electrons or 14 pi electrons or 18 pi electrons. Make sure these are electrons, not bonds. Okay, 1 pi bond contains 2 pi electrons, 2 pi bonds contains 4 pi electrons, and 3 pi bonds contain 6 pi electrons. Okay, so these are the numbers that you need to know. Or if you don't want to remember 2, 6, 10, 14, 18, 22, 26, then you can remember 4n plus 2. This is also called Huckel's rule if you are looking for how to identify the aromaticity of the compound. So in the rule number 1, we said the compound must be cyclic. In rule number 2, we said the compound must be conjugated, or every atom in the compound must be sp2 hybridized if in order to be aromatic. So here's a benzene ring which contains 6 pi electrons. Why? Because it has 3 pi bonds, and if each pi bond is equals to 2 pi electrons, so 3 times 2 is equals to 6 pi electrons. Why benzene is aromatic? Now we have understood 3 rules. Let's apply all of these 3 rules to benzene. Rule number 1, the compound must be cyclic, and the benzene is cyclic. Rule number 2, the compound must have a conjugated electrons. All atoms in the compound should be conjugated, and in benzene all the atoms are conjugated, or every atom of the benzene is sp2 hybridized. Rule number 3 says the compound must obey the Huckel's rule, that is 4n plus 2 pi electrons. So if you have counted the pi electrons, there are 3 double bonds in this benzene ring, and 1 double bond is equals to 2 pi electrons. So 3 times 2 is equals to 6 pi electrons. That's why it is aromatic. Okay, then if you look at this compound, whether or not you don't know this is aromatic or not, so apply rule number 1, it should be a cyclic, it's cyclic. Rule number 2, it must be conjugated, it is conjugated. And rule number 3, it should obey Huckel's rule, which is 4n plus 2 pi electron rule. It means that it should either have 2, 6, 10, 14, 18, 22, 26 electrons. So if you count the number of electrons, this negative charge is equals to 2 electrons, 2 pi electrons. So 2 and 2, 4 and 2, 6, there are 6 pi electrons in this ring, hence this is aromatic. If you count the number of pi electrons in this system, there are 4 pi electrons, hence it cannot be aromatic. Okay, this is a beautiful example where you can use the rule number 3 to understand whether or not this compound is aromatic. How you can apply rule number 3 to identify why this compound is not aromatic: because this compound is cyclic, all the carbons are sp2 hybridized, but instead of obeying the 2 rules, it does not obey the rule number 3, which says 4n plus 2 are Huckel's rule, and it does not have 4n plus 2 pi electrons. That means it has only 4 pi electrons, and it cannot be aromatic based on this rule. So if you look at this compound, this is cyclic, every atom is sp2 hybridized, and it contains 2 pi electrons. This is the simplest example of aromatic compounds. This is a cyclopropene cation. If you look at this Naphthalene, there are 10 pi electrons because there are 5 double bonds. If you look at this tropylium ion, there are 6 pi electrons, it's called aromatic. And here are 8 pi electrons, hence it does not obey the 4n plus 2 pi electron rule, it's not aromatic. If you look at the cyclo 1,3-butadiene, it's not aromatic because it contains 4 pi electrons, hence it does not obey the Huckel's rule. If you look at this, there are 10 pi electrons. If you look at this example, there are 4 pi electrons. As already mentioned, negative charge is equals to 2 pi electrons, hence this is not aromatic. 6 pi electrons in cyclobutene, but 2 anions, dianion. So it obeys the Huckel's rule, and this is again a 10 pi electron system. Another way of saying the same thing is the number of pi electrons is equal to odd numbered pair. 1 pair, 3 pair, 5, 7 pair. This also produces 2, 6, 10, 14. Okay, so in a very short way, you can say if the compound obeys Huckel numbers, it's going to be aromatic, but it should be cyclic and it should be conjugated. Let's classify which compound is aromatic and which compound is anti-aromatic. If any compound obeys two rules, which is cyclic and planar conjugated, and if it does not obey the Huckel's rule, that is going to be anti-aromatic. So there's a difference between non-aromatic, aromatic, and anti-aromatic. So non-aromatic is anything which is not cyclic. Aromatic is anything which is cyclic, conjugated, obeys the Huckel's rule. And anti-aromatic is which is cyclic, planar, and conjugated, but does not obey the Huckel's rule. So if you look at this benzene, pyridine, naphthalene, they all are cyclic, they all are planar, they all are conjugated, and they obey the Huckel's rule. They all contain Huckel numbers, that is 6 or 10. That's why they are aromatic. If you look at these three compounds, which are cyclic, which are planar, which are conjugated, but why they are not aromatic? Because they do not obey the Huckel's rule, hence they are called anti-aromatic. So you need to understand there are three terms: aromatic, anti-aromatic, and the third one is non-aromatic. Non-aromatic is very easy to identify. If it's not cyclic, it's non-aromatic. If it is cyclic, if it is planar, if it is conjugated, and if it does not obey the Huckel's rule, that is called anti-aromatic, and this is a very good example of having anti-aromatic compounds. And these are the aromatics. I hope you understood how to use Huckel's rules, how to use Huckel number to identify the compound's nature, whether or not this is aromatic in character, and you could identify which compound is aromatic and which compound is anti-aromatic. So again, to differentiate between anti-aromatic and aromatic, there's only one difference between aromatic and anti-aromatic. Aromatic and anti-aromatic both have three things common. These two, and aromatic and anti-aromatic, are cyclic, planar, and conjugated. The only difference between aromatic and anti-aromatic is aromatic compounds obey Huckel's rule and anti-aromatic compounds do not obey Huckel's rule, and the Huckel's rule is 4n plus 2 pi electrons, and anti-aromatic contains only 4n pi electrons, hence they are not aromatic. That's why they are called anti-aromatic. Please subscribe this channel and don't forget to share it with your friends. Thank you. Bye.